Hello, welcome back. I've been away for a few days. Have you missed me? Maybe. Last time I was actually going through a talk by someone. And we're still on the question of like building complex functions. I say complex, we're nowhere near anything complex. From simple networks. How legible is that? Not very. I got a new drawing thing. It's a lot better than the old one. So, I think we are in a kind of state of to start thinking up things we'd like to do. So let's try a divisor. I don't think it'll be a good divisor, but one way that we can do division is if we want to do integer division. Then we can ask, so we want to divide n by x. One way we can do that is take x away from n. In fact, to put that in even clearer language, subtract x from n. N goes to n minus x. I'm going to use language that is a bit over heavy, I'm sorry. Iterate a counter. So this is some number I goes to I plus 1. I is 0 initially. Check. Nope, that's not that one. Check if less than 0. So that's n less than 0. So we're kind of updating n each time. And then if not, we repeat. And if it's true, let's call this n naught. So this is ni is ni plus 1. If it's true, we return I. Arguably I minus 1, depending on what we have the counter as. My head's in the way. This happens sometimes. So this is the basic idea. So switch to a new layer. No idea what happened to layer 2. Don't worry about it. So to just recap what we need subtractor and a counter. This basically should be the least version, the worst version of this. So we're going to start with n0 and the thing we're dividing it by x. And I equals 0. We'll just pull in a 0 from somewhere. Should maybe... I think I decided actually that I was going to write with pencil. Quite like that. Don't like that. Do I like any of these better? I kind of like that. Why not? What kind of pencil is that? Or was it felt tip I was going to write with? Does not matter. n0x and I equals 0, so we're just bringing in a 0. A 0 you can bring in as long as you have any extra nodes at all. Hey Lewis, how you doing? So I also want to do a nice just shading of this area. That'll do. So I want to do n0 into a plus. Plus is a 1, 0. I realise that there's no point writing the outs. They don't matter. Nope, that's fine. I want this to be a minus. We'll also just bring... I wonder if I should get some line snapping on this. Yeah, it's fine. Also just bring the 0 through. That's cool. So in fact, one way we can do this that's pretty sneaky is, doesn't matter which one of these we use. I'm going to use this for a node that is 0. I've been good. I feel like I haven't done much streaming in a little while, but yeah, doing alright. Just kind of settling into a pace of life. Still kind of wondering what comes next, but this will give us a I equals 0 and n1 is n0 minus x. We're also going to need to pass x through. I really have made life difficult with the way I've done this, so let's actually move this up there. How have you been? Like, what's been going on in your world? It's kind of fascinating to me right now, like, we can all be living such different worlds right now. That'll do. So, we're just going to put u through a plus operator. And I'm going to put you guys through a plus minus. And we get n1 is n0 minus x, and have you been getting a lot of work in this time? I've been pushing, we'll need x every layer, so I'll just have to keep on passing it through. I've been trying to push, not very hard. Well, I will push hard. I don't yet know where to push for my students to be basically forgiven of work in this period. I just don't think it's very fair asking people to work right now on academic things. And I think there's this picture of like, oh, it's the same working from home. Yeah. I mean, a lot of your school day is not really that full. Okay, so now we have to do the check of... Oh, we actually have to do this twice. We have to get 2 zeros out of this. I'm going to be lazy and give them both the 0 away. We're just going to keep a 0 going. Let's get rid of this. So, we want to ask, is n naught greater than 0? So we're going to have a... Actually, we don't even need a 0 because greater than 0 is an easy enough thing to do itself. It's not like this is a variable, we're just asking if it's greater than 0 always. So we want to put this into a greater than 0 check, and so the thing that's difficult about this network is you had to decide how long you wanted it to be beforehand. Oh, that sounds great. What have you been playing? This is a logical 1. Takes it 1. So if this is true, let's split cases. If this is true, then we would like to multiply this . Then we can multiply it by I, and eventually we want to return this. Now return, we don't have a loop breaker in a conventional thing. Have you put it so that you can put your own music into it, or put like music from online into it? That's basically the only thing that I've really used the Vive for, Beat Saber. We just moved it to downstairs so that we have a bit more room. I'm actually enjoying it. Like it's just nice to have an exercise thing. So I'm realizing with this, we're getting to the point already that we need a loop. I don't really know if I want to get into loops. Yeah. I watched a nice Tom Scott essay recently on. It was something he released just yesterday, where he starts off talking about like how early web things, everyone put APIs in them because they were all just like, yeah, it'd be cool to see how people put these things together. And it's things like that where you're like, well, this is the world that we somehow ended up in instead, where it's not too computationally complex to put these things onto the Quest. Like, the technology already exists for putting custom songs into Beat Saber, it's just making it work with the Quest. But it's a closed system. I've been thinking, don't tell Nintendo. I've been thinking of jailbreaking my Switch. Not so that I can go off pirating a bunch of games, but just so I can start playing with what it can actually do. I have some friends who are always hacking into their devices and things like that, and I think it's really healthy and good. Like, I plan to play about what I can do with this. Right now I'm just using it for the set things, but actually this is a much more free use tool. Like, quickly I found something that wrong key combination. That lets me just draw on top of any screen, including like in-game. So I know it looks like I'm just drawing on the drawing app, but this is an app that always lives on top of the window and just lets me draw whatever. Not that important when I'm using a drawing app, but I'm excited to play with it over the top of games. Also, you can play games with a drawing pad. Who really knew? I mean, of course you can, really. It copies mouse function. How do I get back to pointer? Not that. There we go. So I've got this issue here of, to do this well, I would need a loop. And I'm not yet sure if I want to involve loops, because I still want to be asking the question of what you can do with relatively basic networks. I feel really constrained by like, I'm trying to ask always, what can conventional networks do? What can the ones that are actually at work in people's codes? And this requires me limiting myself to my least favourite word, convention. And all the time I'm looking at this and I'm being like, why is it, why does it come out like this? Is there just a whole sector of the internet that's a big Osu fan? I can see how, like, anything that's really a lot of mechanical skill is really hard to transition through. I've been playing a few strategy games with it. Works well, for example, for hex cells. Arguably better, actually. You know, the thing where I was continuously right-clicking when I thought I should be left-clicking. That's much improved by the fact that right-clicking is now quite a different exercise than left-clicking. So I'm coming up always against this thing where the quiet answer to this is not this. You can't do this counter behavior in a clever way without loops. And whilst loops aren't that alien in networks, like there's a lot of recursive neural networks, I'm just really starting to see how much these networks we're using have to bend themselves over backwards just to do anything at all, really. Just hiding behind my computer. Oh, I like that little hiding space. So can we think of a better way to do division? Than the subtractor counter version? Because let's go into this for a sec. The issue with scheme A, let's call it, is that why does that take so long to draw? This is the kind of time where I would love to have someone who really knows the neural networks. Oh, for the gravity sim. Oh yeah, I had a look at the code you put on Discord. Do you mind if I get it up on the stream? Fair enough if you don't want your code to be seen by the world. But I can try and explain what I'm doing there, which may or may not be a sensible option. Actually, kind of like a break from thinking about this. I know I only think about this for like an hour at a time. Everyone's code is awful. And maybe... Oh, can I just open that? Yes. The first thing I noticed looking at this is it's a very long list of things. Like, you do actually have these displacement, these a few things defined. But it is kind of just a long block of code. And one of the first things that I would, like, you do what you want, but if one of my students showed me this, I would be like, put more things into functions and just try and write less code in general. Like, generally, like, there is totally a case for over-optimization. But almost always you can halve the amount of code you've written. Normally you can reduce it by a factor of 10, and then you go into some crazy thing where you're like using really hard to read memory optimization. But let's have a look at this code, see if it checks out on this. What do I need for F9? No. F10? F11? No. F12? Yes, close enough. So, like, there are definitely places where this is a bit blocky, but I do like to think that it's grouped in terms of doing things that I think I know what they do. Like some setting up a window, putting an SVG in it, some like mapping the window to physical concepts, and then starting on the actual functions. Let's get this bigger. Actual functions being needed, such that everything's quite like separately readable. it's surprising how much function putting in that level of readability has, because you're moving things about shouldn't it shouldn't change anything about how the code works, but it does actually make writing it quicker because it's just easier to know kind of what's happening and what isn't. Ooh. Oh. I thought my website had broken the mouse, but it isn't. It's the tablet. Had the pen resting on it. So what do I do? I have the position of each particle updating. Each particle is an object. So where is? Well, you could argue that the object I'm using should be updated. Oh no, wait. This is the definition of the object. It has an X. It has a Y, which are being given by when I make the object. I know you're using Python, not JavaScript, but same kind of idea. You use an init in the object. This is just making sure that it's going at circular velocity to begin with. Color, unimportant, but just being set by the initial radius. And then I actually define the leapfrog function in the object so that each particle, although they work the same for each particle has its own what do I do next written into it. And that's just doing exactly. This isn't even doing leapfrog. I'm a bad person. This is doing this. Will diverge. Wouldn't be too hard to set this up so it was doing leapfrog. You just put a version of this step before and after that. I wish I could. I know that this would be dangerous, but I wish I could edit this code for online from here. It's just work to edit it from locally. I can't remember if I put sandbox is on here. So I did put this one on. It's really small numbers of particles. This is a more complex simulation. This is full 3D. It's reduced free body, so these particles with colours are not interacting with each other. Apparently I have some options. Can't remember doing that. But there will certainly be better tutorials for making these kind of things, but it is all made here and you can always come and ask me questions about it. If I put down speed, does it update live? Well, it does, I think. There's a lot of quite messy stuff in here. Sometimes, the buttons are some of the hardest things to do. It's not actually too much, but it just takes up a lot of code space. Oh yeah, and I have a color picker. God, this is a complex idea, not very fully explored. I have a color picker where two of the colors do nothing. I should continue working on this. So I use D3 for everything. Which I should just write it down sometimes. Honestly, I'd like to just write some simple code for put circle of this color and this size here. Because I think D3 is a bit over complex in it. But people argue that it's really well made, and I think that probably is true, but I just find it a little overwhelming sometimes. But that's nice. I've got this nice container that everything is within. So where do I actually make these particles? In the function join circles. Function join circles. What do I define? Do I have a second? Oh, I have my own scripts for like drawing things. Can I see this script? So the drawing is actually happening in drawing.js, which may even be, I don't know if don't want to get you in trouble for like plagiarizing, but as far as I'm concerned, that is open access for anyone to use, and I'm delighted if anyone uses it and fixes it. Makes it work better. So yeah, you'd be very welcome to steal and play with that. Can I see drawing.js in any way? Yeah, here we go. Maybe. Maybe useful, maybe a bit too specific. I found, honestly, when I first started using D3, I found it had this really hard for me to get my head around kind of logical flow. It doesn't look much like using a scientific programming language. It makes sense, but it's kind of the way you think about things are in different order, because it's all about attaching things to the DOM, I think. We're getting into the weirdness of JavaScript now, but basically the data is stored in elements of the page. I should go back and play with this sometime. It's very half finished and could be interesting. The point of this is to watch how this particle slows down and comes close to this one. God, orbits are so beautiful. It has this nasty habit, not too surprisingly, of it starts with net velocity in this direction, in the downwards direction. So it does all end up going there. But yeah, I think putting the work in to learn D3 is really worth it. There's a lot of good tutorials on it because a lot of people do it because it is so useful. I would occasionally find myself tearing my hair out, but at the same time, I see people using it and I'm like, oh, I want to use it that well. And that's normally a good sign that it's actually worth putting the time in. Like I look at this every day because it's fascinating and I'm kind of obsessed. And this is all made with D3 in a way that means that it just updates every day with pulling the new data. That's the kind of thing that D3 is really powerful. It's that kind of, it has that kind of generality that you look at and you're like, wow, couldn't you do anything with this? And the answer is you really could. Like, this is what most news agencies use to make their graphics, if they make anything interactive graphics. But you could go well beyond even that. This is from a website made by the people who make D3. And it's full of people writing cool algorithms that are then like partly online. All the code is actually attached to these, so this is a good place to go and see different ways that people are actually making their code. If you click on the ... and edit, you'll see the actual code going into this. This website also has a confusing, like, what comes first structure. Mike Bostock is the person who makes it. Mike Bostock is a little bit of a galaxy brain. Fun data. And I think he has kind of his own methods in his head that are very clear to him, and I still don't feel like I've fully understood. But does this work? But yeah, most things that I've tried to make online, whether or not I've actually gotten through with making them, have been some variation on D3. And it's also just widely used. Like, as far as I know, it's by far the widest used data viz JavaScript tool, which means that it's still relatively young as a language. Like, it's on like its 4th version, but it's still being picked up. And used by people in cool new ways, which probably means it's likely to get easier and easier to use. Unfortunately, the changing code always means there's a chance of stuff you build not working, but I think they also store the old code as legacy code, so you can always, I don't know if you played about with JavaScript much, but like when I first got into Python, I was like, oh, it's so easy to import stuff. You just have to pip install or conda install and then import it, and it works almost all the time. JavaScript's lovely. You just name the place online where the module exists, and you've got it. And the old versions still exist there, so you can just pull out your old one or your new one. Alright, I'm going to stop thinking about this, but it's really nice to have things like this pop back into my head and me be like, oh, let's keep thinking about it. So still, how do we do division? Is the question. So this is an option. Other things I thought about looking at the Taylor series expansion of 1 over 1 plus x, which is 1 minus x. Plus, doesn't matter. Plus second order things. And whether we could get 1 over x out of that. So 1 over x is, I think we can write it this way. No, other way around. One over x plus 1 over 1 plus x. Does that give us anything useful? Oh wait, 1 over x minus 1 over 1 plus x. It's going to give us 1 plus x minus x, such as 1 over x. 1 plus x. Just 1 over x times 1 over 1 plus x. I remember going around this kind of calculation 4 or 5 times in my head, being like, yeah, this will work, and then being like, no, it won't. which using this is 1 minus x plus second order squared of this over x. So we can find this, and we could even change this into, that means that 1 over 1 over x is 1 minus x over x plus things that are now actually first order. So let's write it a different way. Plus 1 over 1 plus x. I had some way where I thought that this worked out and then I realised it didn't. So we get 1 over x minus 1 plus 1. Okay, so we need the order squared stuff in there, I think. I always forget this Taylor expansion. Once, I just would do Taylor expansions, but now I'm lazy. So I just type it into Google. Which often doesn't work. Turns out if you type that into the Firefox search bar, it thinks that it's a web address. Okay, plus x squared. I probably could have worked that out. This sort of seems like it's going somewhere, but I remember thinking that before. So 1 minus x plus x squared plus third order stuff. So we get... Yeah, I remember what this gives. Everything that's left is second order, and this all cancels out to give us that 1 over x equals 1 over x. Which, good news. But we haven't got anything closer to actually being able to find this. This, of course, only works the whole way. We've assumed that the x is small. That's fine. We can do that whenever we want, but I did read a paper at some point. I can't remember where. Is this my own thing? Oh, this looks nice. I should read this. Oh my god, it's 1:30. That time flies. I have to go. Thanks for joining. I'm going to keep thinking about this. I'm going to keep not making much progress. And I'll see you next time.